Now let us discuss an important topic in PDE, partial differential equation, that is called Lagrange's PDE. So this topic is used basically for finding the solution of PDE by using Lagrange's PDE. So here we consider an auxiliary equation like capital P into small p plus capital Q into small q equal to R. So this is our equation, and we take the auxiliary equations as dx, dy and dz. So equating these two with reciprocal with denominators, we find the solution. So I take one problem: solve x into p small p plus y into small q is equal to z. So I will compare this to the equation. So here capital P is x and capital Q is y. So the auxiliary equation is dx by x is equal to dy by y is equal to dz by z. So I will compare first two and these two. So if I take first two, dx by x equal to dy by y, I will integrate. So if I integrate, I get log x is equal to log y plus some constant that I will call it as log c1. Basically it is log x by y is equal to log c1 or x by y equal to c1. Because I'm sending this log y to LHS, so it is log x minus log y, which gives you log x by y property. Similarly, by taking these two, I get log these two equation, that is dy by y equal to dz by z. I get log y equal to log z plus log c2. Log y by z is equal to log c2, so y by z equal to c2. So therefore the final answer is phi of, you have to keep like this, x by y comma y by z is equal to 0. So basically what you have to do is, given problem, you recognize capital P and capital Q, take the auxiliary equation as dx by capital P equal to dy by capital Q, like that, and then just take two at a time, integrate and write it as phi. So like this we can do more number of problems. Sometimes it is easy to integrate, sometimes we take multipliers. So based on the problem we try to use the multipliers. Sometimes it can be integrated directly, in that cases no need of taking multipliers. I will take another problem where you can do directly, but in some problems we will take multipliers, so that also I will show you. I will take another problem. P cot x plus q cot y is equal to cot z. So here also it is of the form capital P into small p plus capital Q into small q equal to capital R. So where capital P is, so this is small p, this is small q, this is small r. So capital P will be cot x, capital Q will be cot y, and capital R will be cot z. So if I take the auxiliary equations, it is dx by cot x is equal to dy by cot y is equal to dz by cot z. So you take two at a time. So it is basically dx by cot x is equal to dy by cot y. You take reciprocal of cot. It is integration of tan x dx equal to integration of tan y dy, which gives you logarithm of secant x is equal to logarithm of secant y plus log c1. Again, by previous problem, I can write this as logarithm of secant x by secant y is equal to log secant 1. So secant x by secant y equal to c1. Similarly, if I take these two at a time, I get logarithm of secant y by secant z equal to c2 log c2. So it is secant y by secant z equal to c2. So finally I can put it in 5. Secant x by secant y comma secant y by secant z equal to 0.